Okay, we're going to look at factoring, which is the opposite of distributing. So last test you were distributing to get the answer. Now they're going to give you the answer and you guys have to figure out what the two binomials were. So our goal is basically to undistribute. So let's review what you guys just tested over. So if I have, for example, let's say x plus 2 times 3x plus 5, okay? I would distribute, or sometimes I call this the FOIL method. Basically the FOIL method just means to distribute, but the F stands for multiplying those first terms. So 3x times x gives you 3x squared. The O represents you distributing to the outer terms, so x times 5x is 5x. The I represents you distributing the inner terms, so 2 times 3x gives you a 6x. And then the L represents you distributing the last terms, 2 times 5, which gives us 10. And then on the test, if we could combine any like terms, we did so. So for example, 5x plus 6x we could combine to an 11x. So our final answer is 3x squared plus 11x plus 10. Okay. So this next test is going to have us be given the answer, and we've got to figure out like what were the two binomials that they used to get those. All right, so for example, the 3 came from the first distributions. The 10 came from the last distribution. This middle number came from the 5x and the 6x, which were that outer and inner distribution. So that's what we're going to have to check sometimes, is this outer and inner distribution, making sure we get that middle term. All right, so before we get started, I want to review with you guys some important concepts that will help us. So if I take a look, you want to write in your notes these perfect square numbers. So in your notebook, write down 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, all the way to, let's go 13 squared. I could have you keep going, but we're just going to stop with that. Okay, and then I want you to answer it as you go. All right, so for example, I started off 1 squared is 1. Okay, so then I want you to do what 2 squared is. So 2 squared is 4. Okay, oop, let's try that again. I'm struggling here. Is 4. What's 3 squared? 3 squared, 3 times 3 is 9. 4 squared is 16. 5 squared, 5 times 5 is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169, and it keeps going on. Okay, so let's see if I can line those up a little bit better here. Okay, the 12 squared kind of got off. So when I say what are your perfect square numbers, these are the numbers that I'm wanting you to be able to recognize. Okay, they'll make your life a lot easier if you see a 4 and you can think of, oh, that was the 2 squared. Okay, so I might ask you, I might say, what number did we square to get the 4? That's 2. What number did we square to get the 36? 6. And so whenever we were distributing, I talked about like the difference of 2 squares and perfect square trinomials. So we're going to focus on factoring special patterns today, and then we'll look at the ones that aren't special patterns later on this week. So the difference means subtraction. So if they are subtracting 2 perfect squares, so if you recognize that they have 2 of these numbers, it's a special pattern. All right, so if they have the difference, the subtraction, and this number and that number are perfect squares, then I can factor it instantly. Okay, and that's going to factor into the sum and difference of a binomial. All right, so this is called the sum and difference. We'll move that here. All right, so this is what our final answer is going to look like if they give me the difference of two perfect squares. Whatever number they squared to get this term will go here. Whatever number they squared to get this term will go here, and one has to be the sum and one has to be the difference. All right, another special pattern that we've talked about is something that's called a perfect square trinomial. Okay, so if they have this first number being a perfect square, and the last number is a perfect square, and the middle number is twice the product of those squares, it's a special pattern, and that will factor into two of the same binomials. And if you want a shorthand, so you can leave your answer as this. Okay, but if you're repeating something twice, you could also use exponents. So I'm good with you leaving your answer as this, or as you can say, I've got two of those a plus b's. Another example of a perfect square trinomial, almost the same thing. The only thing that's different here is the sign. Okay, so if this first number is a perfect square and this last number is a perfect square, and their middle number is twice the product of those squares, this one is going to factor into a minus b times a minus b. And again, you can leave your answer as this. Okay. Or if you want, instead of writing down something twice, you could say there are two of those a minus b's. So I'm good with any of those answers, but these are the examples that we're going to focus on today. Okay, so make sure you have this written down in your notes. It's going to help you out quite a bit. All right, so let's look at some examples. Let's start off and say that I want you to factor, and I'll stick with the special patterns for you. Let's say I want to factor 49x squared minus 64. Right? So we're trying to guess the two binomials that they used, and when they did the FOIL method, that it simplified to this 49x squared minus 64. So this is the difference of two squares. I'm going to shorthand this. Okay. So I'm trying to figure out what numbers are they multiplying to get the 49x squared. Well, my key word to you was that it's the difference of two squares. What number do you square to get 49? 7. So 7 times 7 is 49. Now I also need an x on those terms, so that way I get the x squared. Now looking at 64, what number do you square to get 64? Take a look back at your notes. So what number did we square to get the 64? That was 8. So I'm going to put an 8 here and an 8 here. And the result is the sum and difference. And again, I could distribute this to double check. So there's my 49x squared. If I distribute all the way and I did 7x times negative 8, that would be negative 56x. The inner distribution would be positive 56x. So the negative 56x and the positive 56x would cancel. And then the last distribution would be negative 64. Okay, so there is my factored form. All right, let's try another one. Let's say we had 25x squared minus, let's do 121. Okay, so again, I have given you the difference. They are subtracting. That's a perfect square number, and that's a perfect square number. So we can factor this really quickly. So you're trying to figure out what number did they square to get the 25. 5. Now this had an x on it, so these terms both have to have an x, because 5x times 5x would be 25x squared. Now what number did they square to get 121? So looking back here, 121 was the 11 squared. So we squared an 11. And because they have to multiply to be a negative 121, one has to be a plus and one has to be a minus. And I don't care if you put the minus first and then the plus, it's the same thing. But this is my answer. Okay. Let's look at another one. Let's say they have x squared plus, oh, it's not supposed to be plus because we're working on difference. So let's do x squared minus 4. So again, I still am giving you the difference of two squares. Okay, so if they don't have a number in front, we've talked about how before that this was a 1. What number squared was 1? 1. So I could put a 1x in front of these, or I could just put an x. And x times an x is going to give me the x squared. Now, what number do we square to get the 4? 2. Since they have to multiply to be a negative 4, that means one has to be a positive and one has to be a negative. Okay. All right, now let's look at some perfect square trinomials. All right, so starting off, this is not the difference of two squares. So first of all, it is a trinomial, but it should look similar because 25 is a perfect square, and so is 9. And so for our perfect square trinomial, okay, it said, look at your first number being a perfect square, look at your last number being a perfect square. Now the middle number has to be double the product of those squares. Okay, and this could be a plus or that could be a minus. Okay, so that's another option. And if so, then it's going to factor into that a plus b squared or a minus b squared. So let's take a look. What number did we square to get 25? That would be 5. And I need an x and an x to give me the x squared. What number do we square to get 9? That would be 3. So now the numbers have to multiply to be positive, and they also have to add up to be a positive. So both signs are going to be positives. Okay, so again, we can check ourselves to make sure we're right. So if I FOIL, 5x times 5x is the 25x squared. The outer distribution is 15x. The inner distribution is also 15x. So 15x plus 15x gives me the 30x, and the 3 times 3 gives me the 9. So I can leave my answer as this, or I can say that's the same as saying 5x plus 3 squared. You can write it as a binomial squared or as just two binomials being multiplied. Okay, let's look at the next one. We're going to figure out what the two factors were. So let's look at the first number times the first number. It's got to give me a 49x squared. So again, 49 should kind of pop off to you. That's a perfect square. What number squares 49? 7. Now, they have to multiply to be x squared, so I need an x times an x to do so. All right. I'm also going to look at the last number. The last number is also a perfect square. So what number do we square to get 4? 2. Now, here it's a little bit trickier because it's saying I need to have two numbers that multiply to be a positive. So they could either both be positives or they could both be negatives. But they have to add up to be a negative number. So in that case, they both have to be negatives. And again, let's check our answer. So FOIL, first terms are going to multiply to be the 49x squared. The outside terms, negative 2 times 7x is negative 14x. The inner product, so if I multiply those, is another negative 14x. So negative 14x minus 14x is negative 28x. And negative 2 times negative 2 is positive 4. So again, I can leave my answer as this, or I can say that's 7x minus 2 squared. All right, let's look at the next one. X squared minus 18x plus 81. If you can recognize that that is a perfect square trinomial, you can factor it a lot quicker. Okay, so what number do I square to get an x squared? Well, that would have to both be x. What number do we square to get 81? 9. Now, since they have to multiply to be a positive, they're either both positives or they're both negatives, but they have to add up to be a negative, so the only option is if they're both negatives. And again, check yourself on these. So x times x is x squared. The outer distribution is negative 9x. The inner distribution is negative 9x. So that negative 9x minus 9x is negative 18x. And the last distribution, negative 9 times negative 9 is positive 81. So final answer, we're going to say x minus 9 quantity squared. Okay. If you don't recognize the special patterns, you might be creating more work for yourself later on in the week, okay? So let's look at this one. You know it's going to be a perfect square trinomial because that's the goal of the lesson. What number did we square to get 100? So what number did we square to get the 100? We squared the 10. Okay, so I'm going to put a 10x times a 10x, so that gives me the 100x squared. And then what number did we square to get 169? Also, if you guys don't remember, okay, the list that I had on the other page, you can also grab your calculator. And if you're wanting to see if 100 is a perfect square, you can use the square root button. So if I hit second and then the square button, I'm going to get a square root and I'm going to type in 100. Perfect. So it's perfect square, so I can put down 10. If you're like, I don't know if 169 is a perfect square, I can test it on my calculator by taking the square root. So the square root of 169 is 13. They both have to multiply to be a positive, so the signs have to be the same, and they have to add to be a negative. So it's either a positive times a positive, that gives me a positive 169, or a negative times a negative will give me a positive 169, but the two negatives are going to add up to be the negative 260. So final answer, 10x minus 13 squared. Okay, so square root 100, you get the 10. Square root 169, you get the 13. The middle number should be twice the product of those. So 10 times negative 13 is negative 130. Times 2 is negative 260, so I know I did that correctly. All right, let's say I give you a number that's beyond this 169, okay? You're not going to remember all of the perfect squares. It's impossible. So in the future, if I give you a number like, I don't know, like 225, and you're thinking to yourself like, hey, that kind of looks like the difference of two squares. I know it's going to be an x times an x to be the x squared, but I'm not sure if 225 is a perfect square. Grab your calculator and type in the square root of 225. Oops. And I get 15. So because this one was the difference of two squares, they have to multiply to be a negative, so this is that one of each sign. All right. Good luck on your homework and email me if you guys have any questions.